Today's focus is going to be add and subtract rational expressions. And I just want to remind you guys that you know from the past values to do this. You guys have skills to do this. Just you're not maybe as used to doing it with algebra, but simplifying something like this, you know that you would make a common denominator. So here, these don't have any factors in common, so you'd have to multiply by all the factors from the other fraction in order to make a common denominator and to be able then to go ahead and add it together and then simplify if necessary, if there are any common factors left. However, sometimes when you add fractions, they have denominators that have something in common. I'm just going to write these a little bit differently because it's going to relate to how we're doing. 4 is really factored form of 2 times 2, and 10 can be factored as 5 times 2. They both already have this factor of 2 in common, but in order for them to have a complete common denominator, they need all factors in common. So this denominator here is missing a factor of 5, which I would multiply into the numerator and denominator. And this denominator here is missing a factor of 2 that I would multiply into the numerator and denominator. So then I see that I have 18 over 20 plus 14 over 20, which is 29 over 20. Then I'm able to add them together with their common denominator. This is really what we're going to be working on doing, looking at the factored form of the denominators, finding out what they already have in common or what factors they need in order to make a common denominator and add them together. So looking at the first fraction here, we see the first denominator as 5ab to the third. The second denominator is 3a squared b squared. So notice numerically, the 5 is going to need a factor of 3, and the 3 is going to need a factor of 5. But then also with our variables, we're going to need another power of a, so that we can match up with the a squared here, and another power of b here to match up with the b squared. So the second fraction is getting multiplied by 5b. The first fraction is getting multiplied by 3a. So I have 6ax over 15a squared b cubed plus 20by over 15a squared b cubed. You see the common denominator, so I'm confident that I can now add the fractions together. And my numerator is going to be 6ax plus 20by. Now, whether or not this can be simplified, I cannot combine the terms in the numerator because they are not like. However, they do have a common factor. Both 6 and 20 have a common factor of 2. But factoring that out is not going to help me because it's not going to cancel with anything in the denominator. So I can actually leave it like this. If you did factor it, you could leave it in factored form with nothing canceled out as well. So when we start part B, the difference between part A and part B is that our denominators aren't already factors. Notice in part A, the 5, the A, the B, the 3, the A, the B, they're all multiplying each other, whereas here the terms are being added. So we want to write them as factors, things that are multiplying together. Try and write them in their factored form. So here's what we get when we factor. Notice in the first fraction, our denominator has a factor of x plus 3 and x plus 2. And in the second fraction, 2 factors of x plus 2. So our common denominator, I'm going to write this out so that we can see it. Notice that they both have a single factor of x plus 2. But in order to be the same, this first fraction is going to need another factor of x plus 2. And this second fraction is going to need a factor of x plus 3. And whatever we choose to multiply in the numerator, we will multiply the same thing into the denominator. Whatever we choose to multiply in the denominator, we will multiply the same thing in the numerator in order to keep equivalent fractions in our problem. So I can see now my denominator is going to be 2 factors of x plus 2 and a factor of x plus 3. And in my numerator, I have x times x plus 2 in the first fraction That's being added with 2 times x plus 3 in the second fraction. Now, when I go to add these together, I cannot just start adding terms in the numerator. I need to distribute these before I can then perform this addition. So I have x squared plus 2x being added with 2x plus 6, and that is all over that same common denominator. I haven't adjusted that at all. And then I'm going to go ahead and combine like terms. So I have x squared plus 4x plus 6, and that's all over x plus 2 squared and x plus 3. Now, that numerator is a trinomial. If factorable, I'd want to factor it in case a factor cancels. But as I look at it, things that multiply to make 6 but add to make 4, those don't exist, which means it's not factorable, and this is the most simplified form of that problem. So now looking at part C, I have x minus 5 over 2 times x minus 3 minus x minus 7 over 4 times x minus 3. Now, notice they both have a factor of x minus 3. And remember, 4 is really 2 times 2. So really just this first fraction needs an extra factor of 2. Now, in the numerator, be really careful that multiplying in that extra factor of 2 really means that you are distributing there. Okay? So I can see my common denominator is going to be 4 times x minus 3. And in my numerator, I'm going to have to finish these calculations. I have 2 times x minus 5 minus x minus 7. Now, this minus is subtracting the entire quantity of x minus 7, so the minus will need to be distributed. So I have 2x minus 10 minus x plus 7, and that's all over 4 times x minus 3. I'm going to continue simplifying, so I can combine like terms in the numerator. So 2x minus x, I get x, and negative 10 plus 7 is minus 3 over 4 times x minus 3. These factors of x minus 3 cancel each other out, and I am left with 1 over 4. Please don't confuse this with 4. You canceled out a factor in your numerator. The only factor left there would be 1. So we have 1/4 as our answer in this case. You can do the try these, and if you have any questions, come into class and ask. I will look at the try these part B. I'll do that one on here for you guys. So I'm going to factor the denominator. Now this denominator, again, be careful. You really want it to look like 2a minus 1. So remember what we talked about. If you really want the a written first, rewrite the terms in order, keeping the appropriate sign, factor out the negative, and see if it is the factor that you want. So indeed, this is really negative 2a minus 1. Okay? Now, how to address this negative? Okay. There's a couple of different ways. You know that in a fraction, if you have like 4 divided by negative 6, is the same as negative 4 divided by 6, or is the same as just writing negative 4 over 6. Okay? So with this negative, we can actually just put it into the numerator if that will make our life a little bit easier. So it would be like negative 1 plus a. I made sure I distributed it. So I'm keeping my same denominators. All I did was deal with that negative. Now they both have a factor of 2a minus 1, but this one is squared. So this second fraction needs another factor of 2a minus 1. So that's going to give me the common denominator of 2a minus 1 squared. And in my numerator, I'm going to have 1 from the first fraction plus what I get when I multiply these two quantities together. Okay? So I'm going to distribute, or FOIL, however we like to refer to it. That's negative 2a plus 1 plus 2a squared minus a. I'm going to continue it right over here. So in my numerator, I'm going to start writing things in order and combining like terms. So 2a squared, if I write from highest degree to lowest, would be first. Then negative 2a and negative a would make negative 3a. And 1 plus 1 would make 2. And in my denominator, I have 2a minus 1 squared. Now, I'm concerned that the numerator might cancel and that one of those factors might cancel out with the denominator. So I'm going to go ahead and attempt factoring the numerator and see what I get. Sorry that this got a little bit messy. Let me erase this for you guys. So it seems when I factor, if I'm correct here, I get 2a plus 1 times a minus 2. Oh, no, that would give me wrong. So let me try again. Oh, no, that's not right because I need a positive 2 at the end, so I need them both to be negative. So let me try again. Okay. Does that work? No, that's negative 2, and negative 2 would make a negative 4 in the middle. If this is 2 and this is 1, then they would make negative 5 in the middle. So I'm not seeing it. Yeah, that's not going to work. Okay, so it doesn't actually factor, and this is my solution. So I'm going to leave it that way. All right, and then the last thing we're going to look at in this example 2 is a complex fraction. We'll look at the try this also. So when you're looking at a complex fraction where you don't have the numerator completely combined as one fraction, you really need to work on each of them separately. So I really need to make the numerator all one fraction. Okay? So what these fractions need is they need a common denominator. So I'm going to multiply to these by 3. So this is going to become 3x over 3 plus x over 3, which is 4x over 3. Now remember, this was just the numerator of my complex fraction. That was being divided by another quantity. The other quantity also doesn't have all those fractions combined together, so I'm going to work on that. X minus x over 6. I need a common denominator again, so I'm going to multiply by 6. So this is going to give me 6x over 6 minus x over 6, which is 5x over 6. So my denominator here is 5x over 6. Now we need to do what we did in the previous lesson, and we actually have to go through and simplify this complex fraction. So we need to do 4x over 3 being divided by 5x over 6, which is 4x over 3 times 6 over 5x. The x's will cancel. 3 goes into 6 twice, and so I get a final answer of 8/5. So it happens to simplify to a whole number. So here in the try this, you have 1 over x plus 2 plus 1 over x minus 5. So in order to create a common denominator, this second fraction needs a factor of x plus 2 multiplied in both the numerator and denominator. And the first fraction needs a factor of x minus 5, which will give us a denominator of x minus 5 times x plus 2, and a numerator of x minus 5 plus x plus 2, and that's after those ones have been distributed. So I'll combine together those like terms, which will give me 2x minus 3 in the numerator, and my two factors, x minus 5 and x plus 2 in the denominator. Now, all that did was replace the numerator of the complex fraction. So in the original problem, I can now rewrite the top fraction as my result from the addition problem. But that's still over this other fraction, which says 2x squared minus x minus 3 over x squared minus 3x minus 10. So what I'm going to do is attempt to factor those things also. So x squared minus 3x minus 10 can factor as x minus 5 times x plus 2. And 2x squared minus x minus 3 is 2x, minus 3 and x plus 1. So now when we set this up to actually do the division, we have 2x minus 3 over x minus 5 times x plus 2. And it's being divided by another fraction, which means we're going to multiply by the reciprocal of this fraction. So x minus 5 and x plus 2 in the numerator with 2x minus 3 and x plus 1 in the denominator. Now we can see that we have lots of factors that cancel from numerator to denominator, and we are left with 1 over x plus 1. So this should summarize how you're adding and subtracting. Make sure you're looking for those common denominators. If you're struggling with finding the common denominator, you need to come into tutorial, and we need to work on it because we're also going to need the common denominator when solving.